Okay. Okay. Shakaranja, we're able to model this, do the analysis, and also the design. And the software was able to generate the detailed drawing automatically. So instead of going to Prota Detail, which is here, yana the Prota Detail separate. It's like a 3-in-1 packaging. So, but instead of going there, you can come to Prota Detail directly from the Protastructure. All you need to do is just to come to Drawings and Report tab. So when you come to Drawings and Report tab, you will see by the left hand corner of my screen, top left corner, you will see Prota Detail. You can double click on it. Double clicking automatically is going to load. So it's loading in the background. Nyagama loading, it will come up. Zai kawo kawai in ka double clicking ka bashi zai load. Now, this is the project we are on. Proposed building design. Well, you can start by creating a new drawing. That's clicking new drawing and it won't open design. If I click on auto generate details, it's going to open one proposed building design for us. Detailing in automatically will be generated. So if I double click on that, automatically you see this menu that pops up allow us to do some little settings. But if you come to your option, Zach again some of the information which I may not necessarily go in details for now. But if I click on draw, for example, if I click on draw now, I will just click anywhere around this window. The entire detailed drawing, now one project is going to be generated here. We can go along with each other. We can be doing it together so that so you see it's loading. These are the part footings. That's so this is the entire structural detailing of this project. So you can see this is the foundation layout and this is the part footing. It tells you this is 1000 by 1000 and the depth of that footing. So this information is the cross section, no one column, no one base. And it tells us this is the column that is actually acting on this particular footing, and this is the depth, which is 400, and then the size is a square footing 1000 by 1000. That is what it means. So you can take it to AutoCAD and show the strip when trenches them. This is the slab detailing. Once we omitted this slab. This one by mistake. But this is the slab detail. This is how it's going to look like. Y12. We have 7 number of Y12 at 250 spacing. Bottom 2. This is B2. This one along this will be B1. Concern ana kiran shi bottom top. So this is now the return. It returns and it tells us this is Y12, 2 Y12 at 250 spacing. So that is what it means. Similarly, you can see the column layout. It tells you the size of the column. This is 230 by 230 size of column. We have 4 Y12. So the longitudinal cross section is shini one. So I was trying to explain that we have ground floor, we have first floor, we have second floor. So it breaks it based on each story, but we can make it come straight. This is story 3, column 8. So if you check, you will see story 2, column 8. If you check carefully, you see column story 1, column 8. So it's among all these lists. But instead of going through this stress, you can come to foundation by the left hand side of my screen. If you come to column rather, not foundation. If you come to your column, let's say for example my column 1, I can right click on it and I will click on draw column elevation 2 stories. So it's going to appear in the Kamata. So that again is story 1, story 2, story 3, because it's a continuous column. It goes from the ground floor up to the first floor. You see, this is how it's supposed to be represented. So this is our ground floor. Now from this point, Zua Kasa is the foundation. That is the foundation. The Ganang Zua Nang Kasa. And this side is the ground floor. If you look at this now, this is the thickness of Wanang slab the Kekasa, which is a mass concrete bar, except if you are doing for rafts. Then you have the first floor, which is here. Then you have the second floor, which is here. Wanang thickness na slab ngoni. This is the thickness of our slab. So Nanang is our roof. So that is the detail. You can carefully go through it to understand that. But those in civil will most likely understand better what we are doing. So this is the beam details, and this is the cross section now footing with the reinforcement. So this is how it's going to look like. So staircase, like I was saying yesterday, staircase is an independent structural member. It does not have impact on the building. The loading in the staircase does not contribute to the building. So it is designed separately. But there is a way we can model a staircase directly from Protastructure. But it's a bit more complicated than the regular way the Mona extruding one now. But we can model it from here. But just to show, but it does not really have, it's an independent structural member, because the loading is not Guinea. It's distributed from the slab, it distributes to the beam to the column takes it down to the foundation Nkuma takes it to the ground. So this is basically what it will generate for you. But the good thing about Prota Detail Shine, the template there that we can use. So if you check, you will see it has a staircase template that we can actually clicking one staircase template now. Have you seen it? It's around here. This arrow drop down bar. It's because now minimizing screen, and that's why it's looking. Gashina. Okay, good. It's because screen and regular resolution, so some of the tools are missing, are hidden rather. So this staircase, if I click on it now, all I need to do is to wait for this menu to pop up. You can see we have the straight flight, we have the regular dog leg, which is very common, but of staircase. So however, I think this is the most common type of staircase. So if you check this place that is showing you red line is telling you the support kenan, where it's supposed to be. Maybe a foundation the kuma support where it's supposed to stay. So if it is by the top and by the bottom, you can choose this one. If it is by the side, you can choose this one. If it is by all round, you can choose this one. That's basically what it's showing you. You can see the preview. It's showing you how it's going to look like. So all you need to do is just to pick from here, and you make reference to your architectural drawing. So you will check how many threads we have. So from the number of the thread, you'll be able to know. Then what is the width na landing naka. You can see it's very, very, very user friendly. And whatever you want to insert, like if you check the H now, you can see the story height, which is H, the stair width, which is B. So Zakuga, everything is represented even in the drawing, the one letters. So whatever, you can never be left out. Is very, very user friendly and very it will always guide you on what to do. It's very interactive. So you can see BSK. So if you check here, you see BSK. Are you seeing BSK? BSA. BSA. So you can check from here and impute the information based on the architectural plan. So whatever the architect gives you is what you impute here. So the basic thing coming from here is the thickness. Sai kuma shi ma wannan stair hole din ma is from the architectural plan. Shi ma number of steps din nan shi ma is from the architectural plan. You'll be able to know. All you need to do is to count this. Just count the number. So here it tells you it's very, very user friendly. If you know the life load and you know, yes, you can. Yeah, you can always make reference to one of values. Then you don't always need to be cramming them as an engineer. You can make reference to reinforced concrete books that will always guide you. Acquire standards based on whatever class of building that you are designing for. So so this is basically how it's going to look like. Then by the time you impute all this information and you are okay, you can just click on redesign. Once you click on redesign, you can generate the reports. Now one staircase Shikenova is as simple as ABC. You can generate the reports. Once you click on design reports, it's loading in the background already as we speak. So it's just for you to wait for it to finish loading. You can see, please wait, loading. You can see this is the staircase report. So this is the staircase report. This can be printed and attached to your detailed drawing for approval. So you can click on detail. You can click in detail, it will give you everything that has to do with the staircase. The plan view, the cross section. You can see even the bar bending schedule. This is the cross section of that staircase. So it's as simple as ABC. Similarly, for this is retrofit walls. Retrofitting, maybe you want to add more reinforcement to maybe another failing structure, or sometimes co-achieving Protastructure itself. you can retrofit columns. You can do that. So they are just templates. It's just like common form ni ambaka filling. Once you finish filling it, click on generate it to generate the drawing for you. It's as simple as this is cover, this is part footing. In a case where maybe you just want to design a particular part, maybe you pole na me akikira na nepa. You can easily, if you know the load, you can just do this part here to design the part so that you will know the size of the footing that can be used. If you already know the load, if you already know the load, you can just analyze it from here, click on design, generate the reports, and you can just click on OK. Shimaze generating ma. You can see the detail of that particular footing. So similarly, you can do for swimming pool map, and the swimming pool gives you a template of swimming pool. All you need to do is to select the particular template based on the architectural plan and the Ebaka. So you can see, if I click on select from gallery, you can see different type. However, the swimming pool shape yanazua from the architect, you can just adopt it, and the current design will be deleted. Yes, you can see it has come. So you can just fill in this information here. It's real time. Whatever you put in here from the preview one, Zaogani is taking effects in real time. So all you need to do, once you design, you can insert the soil information property which is gotten from the soil reports, and then that's all. Once you click, it will generate that for you as well. So similarly for retaining wall, and then pile now file, you can also do pile. Look at pile cap. Cover is the same thing. You can do for pile cap, and akwai one other one that is called engineering utilities. One that is very good for, like, if you want to know probably like discharge. If you want to know a discharge, if you know the section of your rectangle, you can solve. If you know the flow depth, you can input all this information automatically. Generating one. Just check. You can pay attention to the information here. You can see the fraud number here. Discharge quantity is 11.17 meter cube per second. So if that is correct, you can change the information here. Let's say I put in this information to 2000. You can see the value of my discharge has changed. So it's always very good when you want to calculate whether a uniform load, uniform flow depth, or gradually varied flow. So it has unit conversion one that you can convert from meters to millimeters, from area you can convert to millimeter squared. You can convert to any one. You can see mass, you can see pressure and stress, you can see force, and all of those can be converted automatically. Just put in the information, type in information, and it will change that for you automatically. And you can analyze a simply supported beam. Can be analyzed from here. The length of the beam, all you need to specify. So you can analyze a simply supported beam from here. Just put in the length of that beam, the load of that beam. I know I'm already making it very boring at this stage. I know a lot of people. No, okay.
They are following you. These guys are following you.
If not for the civil guys, some may not really get what I'm saying. So it's going to be really boring for them here. Say they civil, that's the gun. So this is basically all you need to.
It's not really boring. These are all familiar.
Okay. Okay.
And I, as an architect, engineer, I'm a veteran engineer for the past 20. For the past nearly 3 decades.
Wow.
Yes. 25 years I've been with them.
Come on, in the case of wherever you are designing hydraulic structures, I must fish once you hydraulic structures.
So that's basically even your hook length. Come on, kind of site here, so you want to really determine the hook length, naka, and all. You can quickly do that coming here. So instead of doing all that or using rule of thumb, you can just come here and calculate, just put in the information, bending length, extension length, and all that. Cover immediately Zebaka information in cap. So it's very good and very handy. It's a very great software that you can use to do a whole lot. Like I said, there is a whole lot we need to really do with Protastructure, because there is still more that we can do. We can take a cross section of our slab. For example, this particular slab now, if I want to know the cross section of this slab, it's very easy for me to do. I think if I come to detail library, if I come to this detail library, I can click on slab plan section. If I click on plan section, all I need to do is to click on the first point. I will hold on control in order for me to have a straight line. Very important. Straight, but how to get this is how to get a cross section. Now this is the cross section of this slab, which we can get because by generating mana automatically, but you have to come and take a cross section. So not just only a slab, any structural member, you can get a cross section. Coming to this detail library, just click on plan section and it will give you a cross section. Again, you got automatic dimension Shima. It can give you an automatic dimension. Yes, it can give you an automatic dimension. Yeah? By auto mode ba? Good. Like I said, you know the interface. There are a lot of relationship with AutoCAD. To manipulate AutoCAD, you can as well use this very well. For example, type in CO for copy. For those that are familiar with AutoCAD, I can easily copy my file. You see what? If I type E now for erase, I can erase this. Just the same thing with AutoCAD. So shortcut keys na Prota detail, the AutoCAD is 100% the same. So I can have an automatic dimension. All I need to do is to click on auto dimension, click 2 points. So you don't really necessarily need to even take it to AutoCAD. If you can manipulate it from here, you can actually do your editing from here. Basically, AutoCAD. Unlike this reinforcement that is here, I can erase it. I can erase it, or I can move it. However I want, because the shortcut keys in AutoCAD, the one now is the same. So the advantage of having it in AutoCAD, you can have pre-existing maybe other designs that are already there that you probably just want to use to do some little editing and so on. So this is basically how to generate your detailed drawing here. Maybe I should pause here in order for me to take questions. Kuma, I should proceed. Let me know, because I have gone a bit far. Kuma now.
Questions?
Nobody has a question, what?
Because you are super.
Sir?
You have explained everything to them. They have understood it.
They never asked you about cantilever slab, cantilever.
Abubuwan suna da.
Nobody asked all these things. Like incline column.
This one abubuwan suna da. This zamu taba ramp. This zamu taba. In daytime ya permit. Ka san abun yana da fadi.
You cannot exhaust it.
Yana da fadi.
While you are doing it.
So, but if we are clear from here now, for example, if I'm not satisfied, I want to export these drawings to AutoCAD. All I need to do is just to come to my file, and then another file, then I will come down here. You see exports for external softwares. All I need to do is to export to DWG/DXF. And Kuma, this is the format that AutoCAD yana recognizing. So once now exports, she can automatically it will be generated for me. All I need to do is to open it in my AutoCAD. So this is the drawing. Yes, sir. So if I double click on it, automatically it's able to AutoCAD continue. So this is the drawing here in AutoCAD. You can see the entire drawings have been generated in my AutoCAD. So all I need to do is just to arrange them properly and print. I don't know if it is making sense.
Yes. How is the details of details?
Sir? Plan.
Slab details.
Slab details. This is the slab detail.
No, I know how to input the data for you.
Okay, we're now Protastructure ni, but Prota detail. Okay.
How is it done?
Oh, you were not there, huh? Oh, okay. Wannan sai dai mun fara afresh kuma kenan.
Go ahead.
Okay, but let me just.
Okay. Just go ahead.
Okay. So these are the entire reinforcement details. All you need to do is just to arrange them properly. Like me personally, what I do is I will always arrange my foundation layer. Comes first, then column/base detail. So let's assume Chewa, this is just the column that is going to be on the structure, because practically you don't have to keep repeating the same column over and over again. Why are we printing all these columns? Because if I'm to do this detailing manually, I may adopt just one type of column for the entire building. So in that case, you can just have just one column, except in a case where maybe cross-sectioning is different. Cross-section and Kuma length then, because we have columns that can terminate on the ground floor. We have columns that can start from the first floor. So in that case, you are having different types of column. But in this case now, we are going to have almost the same type of column, because even the software, when it analyzes and does the design, that you will see that everything are approximately the same. The reinforcement, the links, and so in that case, you can adopt just one type of column. So there will be no need of you printing all these columns. Then you take the cross section. This is longitudinal cross section. You can now take. You can see the cross section from the plan. This is how it's going to look like. But from the this is the longitudinal section, which is showing us the entire one from the ground, from the foundation up to the roof level. then you can have your base footing, which is going to be here. When you have the foundation layout, you need to show the column and then the base, and then you can have what we call the slab and the beam layout. Slab and beam layout tells you that was not generated, but this is basically how the slab and beam layout is going to look like. Sir? Okay, but not capture it. Aha. So the slab and beam layout. Then you can have the slab detail. But now I'm not deleting cross section. Cross section is there already, so you can just have the cross section by the side, the slab. Then you have one number. It's not necessary, but you can put it maybe by the side. Now, she one can just be here. This one can be here. This one can be here. You can attach their schedule to them. Then we can have what else? Then she beams then. So beams then has to be sorted in terms of stories. So each story will be separated based on their story. So if we have all these beams here, and we have the beam, the last we can have, after the beam we can have the roof beam, which is story 3 here, which is this. Say maybe lastly staircase can come. Just put them in a rectangle like this. So this is basically
I think we need to put a break by 3:30.
Sir?
We need to put a break by 3:30.
3:30, what? Okay, this is 3:30 already, what?
Yes.
Okay. So we should stop now. Okay, so as it is, I have already literally finished the arrangement of the detailing. Say the cover, you just put it on a template on untitled block. If you have, you should have a pre-existing layout. Yes, sir. If you have it, you can just arrange them. But this one has to be sorted well, because I think all the stories are... So me, what I normally do, these beams, I will just delete them when they are generating them automatically. I will delete them first. I can just delete them.
Why?
We'll do the sorting from here. Let me show you what I will do. If I come to these story beams, I will generate only the story 1 separate. You see it's separate now. I can also generate the story 2 separate, so that ba sai na je wutu kana zo na tawalan kokarin rearranging din shi. Then I will generate the story 3 separate shi ma. once I have it like this, however I like, I can put it anywhere in the window.
Yes.
Now exporting, then Chang AutoCAD, I can rearrange it properly. So once I have it like this, my entire detailing is 100% ready. It's just for me to probably come and generate my report schema. Each of the reports, I can print them out, either from drawings and reports. Kokoma, I can as well even generate the drawings from Nazo post-analysis, the beams, the columns. I can generate all my reports from post-analysis, but onto column/wall. I can come to reports here and design reports. So na clicking OK, they're generating my reports. Na columns.
Okay.
I can now see where we are having some columns and coming up in rooms in our architectural drawings.
Okay, a chicken daki. It's from the general arrangement. That, if you as the engineer, you must have a very good insight in architecture. If you don't understand how to interpret architectural drawing very well, you can place a column in the window. So it boils down to understanding of your structural layout, which is one of the basic knowledge that you need to have. It comes with years of experience, a field, and all that. This is the report.
These things are things that you cannot get in the classroom.
Yes.
It's from experience.
Exactly, sir. You can't get it in
Long interaction with architects
yes, sir.
and other professionals.
Yes, sir. So it comes with years of experience. Over time, as you keep going, your design will continue to improve. Your design will continue to become more economical. You will see some because they are scared. That's also beam man roof my K600. But as you begin to grow in the profession and become more mature, your confidence will continue to increase and all that. So, but this is basically how the report is going to look like. So all you need to do, you can change it to PDF or to Office file, however you want it, or you can print directly from here. Add this to a PDF. Kaweze Budemana proposed building design RC column design. So this is the report for my column. If I click on save, so similarly, the same way you do for your column, it's the same way you do for every other structural member. You can just go there and click on report.
Those who design the software use their best. Even for people to follow even what they have done is taking time. Not to talk of we doing the design itself.
And
you need to appreciate all these things.
And honestly, sir,
Yes.
this is structural design software you can ever learn.
So you can see there are more advanced ones which are more complicated.
This is one of the most simplest. This is one of the most simplest one you can ever learn.
Not to talk of even you guys, growing to design, to produce a software which will solve these problems yourself. This is what we're aspiring in this country.
Amen, sir.
Chairman, I hope our practices. Yes.
So this has already been saved as a PDF. As it is, I can send to my clients
Correct.
the PDF.
Wonderful.
He can encounter. So similarly for for other structural members, like if I come to the beam, it's the same thing. If I come to the beam, but there is another. In the azote column from experience, if you print all this, by the time Kagama printing report, it will look like a textbook. So it will be too much. It will be too bulky. It's not necessary. You are repeating the same thing over and over again, because all these columns, we have a lot of similar columns. So what you do, if you know that all your columns are similar, you have a lot of similar columns, all you need to do is uncheck all this one. You can uncheck them. You can uncheck them and specify the particular one. Remove print mark. Now removing print mark, I will just come here and trace story 1 column 1. I will look for story 2 column 1. I will look for story 3 column 1. I can just pick the most critical of them. Same printing. When I know that all the columns are the same, but the cross, so I can print just this one.
Okay. Just this one?
Yes, just these 3. 1 and 3 is telling you Chewa is the same column, but she knew one. This is ground floor in Kenan. This is first floor in Kenan. This is second floor.
Yes.
So instead of printing everything, by the time you print, say Zaka gang ajunka maya. So it's better you save yourself cost. And
sometimes you will need to do these things because there are some supervisory bodies who would like to go through all these
Some
details.
approval authorities will ask you to submit
Everything.
yes, sir.
Whether they are repeating or not, like what we experience in Abuja.
Dole za su karba. But
But
if you have,
it is a, you know, if you have a private,
yeah,
you know, client.
yes, sir. It comes with your arrangement from your foundation layout. What I will do from the foundation layout here, I will name all the columns instead of FC1, FC2. I will name all of them column 1.
Okay.
So I'm printing one report because it's just one column.
Exactly.
It's just one column name that is repeating over and over again.
Yes, yes.
Whoever is vetting your work, if he's very experienced, should know that all those other are not necessary.
Yeah.
If you are naming all of them one column, then you are having just one column.
Exactly. Same character.
And then the report is supposed to be just for one.
Why?
Except in the case of beam. Beam maana some similar beams. You can have a similar beam. In a case where you have a similar beam, there's no over and over again. You can print just specific. You can have 5 beams that could be beam 1. You can have 3 beams that could be beam 2. When it comes with maybe detailing no AutoCAD, manual detailing no AutoCAD. That is when you have deeper insight of what I'm doing. Because right now there is a whole lot that Protastructure is doing for us in the background. So that manual detailing, that's when you have a deeper insight of what I am talking about. It will make more sense.
When you repeat it yourself, you know what you're repeating.
Yes, sir. So as it is, I think we have finished this project from entirely. We have finished. Say we can go into steel if you want, or let's go for break. I'm in the Ugayachi.
Good. Well done.
Yes, sir.
Super resource person.
Thank you, sir.
Inclined column back.
Sir?
Inclined member.
Okay, is that now?
Leave on a slab.
Okay.
Or irregular slab.
Okay. Okay.
Or cap slab.
Okay. Pardon.
What design just simple uniform structure. Where you have
What